In this video, we'll focus on the very important command that allows us to run through or iterate over the records of an entity, so that something can be done with each record's information. This command is called for each. In this case, since we want to iterate over the attraction entity, we'll write for each attraction. We will call the entity base transaction of the for each. From the attraction base transaction, GeneXus infers the attraction table in the database. The for each command contains a code block that will be executed sequentially in each iteration. Here for the first one, again for the second, and finally for the third. In this case, there will be 3 iterations because the table has 3 records. Where can a for each command be written? Anywhere code that accesses the database is allowed. For example, in a grid system events. If we want to load the grid one that we have been working on since the previous video with the tourist attractions in the database, we can use the for each command in this way, inside the load event. Note that we are assigning to the variables the value taken by the attributes for the record in which the for each is positioned in each iteration. Here we are in the first iteration. 3 of the attributes are those of this record, but one is from the extended one. So to retrieve it, it will be necessary to access the country. This is solved automatically. We just name the attribute we need, country name. And GeneXus takes care of the rest. This will be repeated for the second iteration, and then for the third iteration. Note that each iteration ends with the load command, which will load a row in the grid with the values of the variables. Let us note at this point that there will be an easier way to load a grid from an entity, but it is based on the same logic as this command. So understanding it becomes vitally important. In the web panel we are going to replace the code of the load event of grid 1, which was used to load fixed data, with the one we have just seen. We write, for each record of the base transaction, attraction. And then we go to the block of code that we want to be executed for each attraction, and close the command with end4. In the code block, we need to copy in the variables the values of the attributes. Let's run this to see the result. F5. We see that now the web panel shows the 3 attractions that we had stored in the attraction table. And notice that they appear in order according to their ID. Let's go back to GeneXus to see how it informs, through this navigation view, its decisions for this web panel based on the code we wrote. We can see that next to where it says for each, it also says attraction, indicating that this is the base table of the for each command. That is, it's the database table that will be navigated or iterated by the command. Remember that the for each runs through a physical table. So the name attraction shown in the navigation list refers to the physical table attraction, not the entity name specified in the code, which corresponds to its base transaction. GeneXus infers this table because it is the one associated with the transaction we referenced. Further down, the report indicates that the attractions were ordered by the attribute attraction id, the primary key of the attraction table, using the iAttraction index, a primary key index that, as we saw earlier, was automatically created by GeneXus when the table was defined. All its records will be retrieved, iterating from the first one, until the end of the table is reached. That is, it will iterate over the entire table. Finally, it shows that, in addition to running through the attraction table, it will access the country table to retrieve the country name so it can be displayed on screen. That is to say, from the attraction-based transaction, GeneXus gets its base table and its extended table. inside the for each we have the attributes attraction id, attraction name, and attraction photo, which belong to the base table. That is, the table that will be run through record by record. And we also have country name, attribute of the extended table. So the country table must also be accessed to retrieve it. Therefore, the attraction table is run through and the country table is accessed. That's why only these two tables appear in the navigation list of the extended table. We saw that if nothing is made explicit, the for each runs through the records of its base table, in the order defined by its primary key. Here, attraction id. How do we change this order? Let's suppose we want the sorting to be done by attraction name, so we can see the grid sorted alphabetically by attraction name instead of by ID. To do this, we use the order clause of the for each command, which is placed immediately after the base transaction. Let's run it to see this change. There we see it. If we analyze the navigation list, we can see that it now indicates that the attraction table will be run through in order by attraction name. We also see that it is using the user-defined index of this name, which we had created when we studied unique indexes, to ensure that attractions with the same name could not be repeated. Since it exists, it is proposed for use. Now let's try sorting by country name, which is an attribute in the extended table of attraction, but not in the base table. Let's run it. F5. First comes the attraction from China, followed by the two from France. If we look at the navigation list, we can see a warning indicating that the query must be ordered by country name. But in this case, there is not index for that attribute, so it could potentially degrade performance. Could doesn't mean it will. The responsibility for data retrieval efficiency lies with the Database Management System, DBMS, which uses strategies for retrieving data that are unknown from within GeneXus. Therefore, GeneXus only reports what it knows, that no index is available. In the worst-case scenario, the table would need to be sorted by country name before it can be run through. But as we said, most likely the DBMS has better strategies. GeneXus leaves it up to the DBMS. If we now want to sort by country name, as shown here, but also by attraction name for entries with the same country name, it is enough to list those attributes in order. If we run it and check the navigation list, we will see that the two attributes are included in the order clause, in that order. Here the order is ascending for both attributes. But if we want to sort in ascending alphabetical order by country name, and within it, when records share that value, sort in descending order by attraction name, it's enough to enclose that attribute in parentheses. By pressing F5, we now see this reflected in the list. And if we run the web panel, we see that the attraction from China appears first, followed by the two from France, with the one having the alphabetically greater name listed before the other. Let's now set the order exclusively by country name again. And suppose we want to get only the tourist attractions located in France. To filter the data to be retrieved by the for each command, we use the where clause, which goes after the order clause. We need to specify that each attraction record should be kept according to this order, where country id is equal to 2, which we know is the ID of France. We press F5 and run the web panel. Only Louvre Museum and Eiffel Tower, the two attractions from France, are displayed. The one from China does not appear in the list. If we review the navigation list, we see that GeneXus reports the filter condition in the constraints section. This list can be interpreted as follows. The for each will navigate the attraction table, ordered by country name, for which there is no index. It will run through the entire table from beginning to end, but will only keep each record if it meets the condition in the constraint. Otherwise, it will be discarded. The requirement to filter and iterate in the for each only for attractions in France would have been more natural and safer to implement using a condition based on country name instead of country ed. This is because we might make a mistake with the ID, it might not be 2. At runtime, the result will be exactly the same. However, in the navigation list, we can see that the condition now appears in the navigation filters and not as constraint. The reason for this is the order. It's like when we search for F in a dictionary. We don't go through the entire dictionary from beginning to end. We go straight to the F. Here, it starts at the first France record and iterates until the last France record. It never reaches the record for the attraction in China to evaluate the filter. The condition of the where clause can be any condition that returns true or false, simple or compound. For example, if we want all attractions that do not correspond to country name France, we can use the logical operator not. But we could also write the filter with the arithmetic operator not equal to, which is written in Ginexus with less than and greater than. It reads where country name is not equal to France. In either case, only the attraction in China will be displayed. What if we only want the attractions in France whose names come after L alphabetically? Here we are saying that 2 conditions must be fulfilled at the same time. That the country name is France, and that the name of the attraction is greater than or equal to the letter L. That is why neither Eiffel Tower, which meets the first condition but not the second, nor the Great Wall, which does not meet the first condition but does meet the second, are included. We will only see Louvre Museum in the grid, which meets both conditions. Let's try it. Here is the navigation list. As we can see, attraction is run through according to country name, which, with the data we have in the database, would be as if we had the country table sorted as follows. First Brazil, then China, and then France. Then we can have attraction sorted as follows. First the attraction in China, and then the 2 in France. The navigation filters indicate that it will only iterate between these records here. The previous one will not even be run through. These will be run through one by one, querying the constraint. This one complies, so it is retrieved. This other one, however, does not, so it is discarded. Equivalent to having a where clause composed of AND operators is to have several where clauses. That is, to write the for each like this. Here we show the syntax of the for each command as we have seen so far. It accepts more clauses, but for now we will show only the ones we use. In the syntax, the square brackets indicate that this part is optional. It could be omitted. Thus, we could omit specifying the base transaction, order clause, or where clause. Here we specify which entity will be run through by the for each. By entity, we mean both a transaction and a sublevel of a transaction. For example, both country and country city. Suppose that in a grid we want to display the names of cities. In the load event of the grid, we would program this for each. Here, the entity to be run through will be the sub-entity of cities. From the base transaction of the for each, corresponding to a first or second level, its table is extracted from the database. And, as we have been repeating, whenever we are working with a table, we have the extended table available to complement the required information. The base table will be the one that will be run through by the for each. Here we can see a for each with base transaction country, which will list the names of countries in a grid. The fact that the base transaction is country means that the base table which is run through will be country. In this case, its extended table is itself. And here we have the for each with the base transaction country, city. That is, the one corresponding to the sub-entity representing the cities of the countries. The grid will then list the names of all the cities registered. The base table of the for each will be the table associated with the second level of the transaction. Its extended table also includes country. For example, we could display only cities in France like this. The table run through will be country city, but its records will be filtered according to the value of the country name in the country table. This last example makes it clear that all attributes found in these clauses and in the main code must necessarily belong to the extended table of the base table to be run through. Using the order clause, we can indicate the criteria by which to sort the information returned by the for each. The order can be based on attributes from the base table of the for each, or from its extended table. It is possible to sort by a single attribute or by multiple attributes. If no order clause is written except in specific cases, a for each command will always choose to have its base table run through according to its primary key, for which an index is always created. To filter the information returned by the for each, the where clause is used, in which we specify the condition that the records must meet in order to be selected. The condition can be simple or complex, including all logical operators among the options. We saw cases with not and and, but it could also be with or, where the result of the compound condition is true if either of the two conditions, the one on the left or the one on the right of the OR, are true. In the latter case, attractions in France will be listed, as well as those outside France, whose name is greater than or equal to L. We can also place several where clauses, which is the same as writing a single one, with the conditions joined by AND. Once the base table for the for each command and its extended table are determined, in the main code we write the commands that we want to be executed, one after another, to perform, step by step, the required operations on the current record of the base table and its associated records from the extended table. This code will be repeated on each iterated record. In this video, we use a for each command in a web panel event to retrieve data from the database. However, the for each command can be written anywhere in any object that supports sequential code. For example, in a procedure object, which we'll cover later. In other forms, the same navigation logic and the same concepts of base transaction, order, and filters will be found in other objects, such as the data provider, controls, such as the grid with base table, and formulas, such as aggregate formulas. That's why understanding the for each command is understanding GeneXus logic for accessing and navigating an entity's data, which will be repeated elsewhere in other forms, but keeping this consistent logic.